Hello everyone, and this is the video for chapter 2.1. Okay, let's get started. Refer to the table summarizing summer time. So these are times it takes to get your food at a fast food restaurant. How many individuals are in the summary? So all we have to do is add the frequencies. So let's start off with the 25 and the 15. So 25, 35, that's 40. Then let's add that 9 for 49. Add the 2 for 51. And add the 5 for 56. So it should be 56. I don't know if you get this fancy screen, but that's how it looks like on mine. Okay, is it possible to identify exact values of all the original service times? That would be a no. We know that there's 9 in between 60 and 119, but we don't know like exactly what number those nine different times were. So this is a no. The data values in each class could take any values between the class limits. So it's C. Okay, let's go to the next one. Heights. Okay, heights of a normal distribution, good. So normal distribution, just a reminder, it kind of looks like this. The frequencies get bigger and then kind of start dropping. So they're just telling you that, well, this actually doesn't do that, but they're telling you it's normally distributed, but if you look at this one, it starts at like 23, then goes to 25, then comes back down to 22, then shoots back up to 26, and then shoots up to 28. That's definitely not normally distributed. So number one's definitely true. So read through number one. And the sum of your probabilities, your relative frequencies have to be 1 because it counts for all the data. Percents are okay. The reason that D is not true is it's not that it didn't allow it. It's just that there wasn't anybody at that height. That's why there's no frequencies. Okay. So hopefully this is right. Okay. The lower class limits, the upper class limits. Okay, so the lower class limits are the 10, these guys right here, 14. I know sometimes I can't figure out a way to bring a pointer in so you know what I'm talking about, but these are all them. So 16, hopefully there's a easy way to do this. I'm gonna bring my thing up. I don't know why I did 16, it should be 10. Definitely fast forward through this stuff if you'd like to. Okay. Okay, now upper class limits are just the upper parts of these, so 11, 13, all the way down, so I'm trying to like tab over, but it's not letting me. Open, go. 21, and 23. Okay, good. Check that answer, good. Okay, the class width is going to be the first lower limit minus the previous first minus limit, so it's going to be 2. So kind of be good at that one. That's tricky sometimes. So you could look at it as like, you could look at it as 14 minus 12, 16 minus 14, etc. Okay, the class midpoints are what's right in the middle of each class. So if this is 10 and this is 11, then the class midpoint's 10.5. It's whatever's in the middle of your class. If you didn't know how I got that 10.5, I just did 10 plus 11 divided by 2, and you'll get that. So if it's a complicated number, just take the first one, add the second one, and divide by 2. Okay, so let me see if I can get faster at this. Okay, 10.5. Oops, sorry, it's 12.5. Glad I looked at that. It just goes up by 2, whatever the class width is. Okay, good. I'm just going to double check because I don't want to get it wrong. Okay, good. And the class boundaries. This one can be kind of tricky because what you have to do is go to this 10 and 11, and you have to count back a half and go to 9.5. Now you have this 12 and this 13. The next one's going to be 11.5. The class boundaries are like, if this was an x-axis, it would be like 9.5, 11.5, kind of like up and then up by 10. And like we did earlier, we just go up 2. You could definitely fast forward if you kind of get it, or just do it. Working on an iPad, so it's a little cumbersome. The last one should be always a half more than the largest class. So see how that's... Okay, so you want to leave the question? No. Okay, see the 23 on this, on the last class, the 22 to 23. Your biggest class boundary should be a half bigger than that. I'm not doing another one of those if it comes up. I apologize. Okay. Oh, identify the number of individuals. Oh. Okay, so let's just do this out. 29, 36, 13, 3, 4, 2, 1. 2, 1. Okay, let's just do this long way. 15, 18, 21, 25, 28. Okay, 4, 7, 8. Oh, I hope there's this many. Let's do it real quick. 30, 30, that's 50, 65. 78, 81, 78. I'm going to try it. If it's wrong, then it's wrong. Okay, good. 4. Okay, does the frequency appear to be a normal distribution? So to be a normal distribution, we're going to count up. So 3, 0, then it goes 14, it shoots up to 13, back to 9, 7, and 1. Okay, the second one's not true because it does decrease from the maximum. 13 is the maximum, it decreases. I'm going to say yes, and if it's wrong, then I won't ask this one. Okay, I'll do similar. So what they're saying is because of this guy right here, they're saying no. Even though it really is, but I won't ask that one. Okay, here's another normal one. So it goes, let me go down here a little bit. Right, straight line? Nope, nope. Let's get a better straight line. Okay, good. So it goes 1, 2, up to 5, up to 15, back down to 5, down to 4, that's 1. That's definitely a yes. That doesn't sound good. Wait, so start low, proceed to higher frequencies, then decrease. So it sounds like C is right, so I like C. Oh. Okay, this one's definitely not fun. Okay, so I'm just going to tell you how I'm going to start this problem to fill this out. So I'll do 3.470. And they tell me 30 screws, construct a frequency table. Class width of this, 0.010. So what you have to understand is this next one up here, the one right below, like this one right here, that's going to be this much more than that. Okay, so if you did the math, it would look something like this, and I could read this later. So 3.70 plus 0.010. So what we're going to do is try to develop a pattern real fast. So that's 4.80. So this first one is 3.480. Oh, darn it. Wish there was a way I could just type it in there, but it's not letting me. Okay, 3.480. Okay, so if we add that, so this is 3.480. So if we add another 0.10, that's the next one, you would get 3.490. So let's take care of all these first. I'm going to do all these down the line. So 3.490, 3.4, oh sorry. The next one's just going to increase up by 3.500. Technically, you don't need the 0 zeros, but we'll just do it to kind of stay consistent. 0.5. Okay, good. Now, this one right here is just going to be, so now I'm looking at this one up here. So let's get rid of this thing. So now I'm looking at this one right here. So no, this is, this one right here, it's 3.480. So this one has to be 3.479. Because that's like the next number that's less in the that's called the thousandths. And the next one's going to be the 89. You guys have probably already figured this out in my Wednesday class, or why do I keep doing that? 409. Just going one less than this number. Now just go up to 19. Okay, now that we have all those things in there, we have to attack the frequency. So I'm going to open up the data. So here's your data. Okay, so I'm looking for how many of the data are in between 3. Let me just clean that up. I'm looking for how many screws are between 3.740 and 3.479. Okay, data table. And usually though they're pretty nice about putting them in order for us to make our lives a little easier. Oh, there it is right there. So I'm going to click on that and open it in StatCrunch. Hopefully. Maybe. StatCrunch. Try it again. Okay, very good. So what I'm trying to do is order them from least to greatest to make my life a little easier. So it doesn't look like it's going to let me do it in this application, but this should work if I hit data and then sort. And I'm going to do ascending right there. Hit compute, error. Okay, I have to select who I want. Variable 1. Compute. Okay, you see they're in order now. So I'm trying to find out how many are from there. So it looks like there are 2. 2 between there. So I'll just go back. I can get rid of this now, and there's 2 there. Now I'm looking between how many between 3.480 and 3.489. Okay, and I'm just looking right at my StatCrunch. Looks like there's 4. I'm looking from row 3 down to row 6. So 3, 4, 5, 6, there's 4. Okay, now 9 to 9, 9. 9 to 9, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8. I got 8. You could go back and look at this thing if you need to. Okay, next one. Oh, I gotta go back to see which one I've done. Okay, looks like I'm on the 5s now. Okay. Okay, 500. Okay, so I got 1, 2, 3, 4. I'll just talk about rows. Row 15, row 16, row 17, row 18, row 19, row 20, row 21, row 22, row 23, row 24, row 25, row 26, row 27. Okay, so I messed up my count, so I'm going to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I got 13. The worst thing is, you probably know, is when you do all this stuff and it's wrong. Oh, no. I forgot the 9 nines. Okay, I don't know what happened. Hope this doesn't get messed up, but 1, 2, 3, 4, 5, 6, 7, 8. I have 8 there. 8. Probably had 8 there already. Okay, and let's do the last one. No, it's kind of painful. This is basically just whoever's left. Looks like there's 3. Now I know why people were saying it takes a long time. Okay, let's check. Keep your fingers crossed. Okay, good. Okay, so this one seems a little difficult, but it's not too bad. So what we're going to do is the relative frequency is a percentage of how many cigarettes are in the 3 to the 6. It's non-filtered and filtered. Non-filtered and the filtered. So I'm looking for, okay, non-filtered. It doesn't look like there's any from 0 to 6. You see there's an 11 by 14. 11 to 14 is the smallest amount of tar. And there's 2 there, but there's none from 0 to 6. So what that means is over here, that's going to be, 3 to 6, there was none. So there's 0 there. Okay, the lowest was 14 to 17, so I know that's a 0. This is a 0. Okay, now 11 to 14, there was 2, but we have to be careful because it's a percent. So we have to figure out how many are in there all together. And there's probably 25. Okay, 15, 21, 22, 23, 24, 25. There's 25. So 2 over 25 is the same thing as 8%. You just put it in your calculator, you'll see 0.08. The way I did it is just times this by 4 to get 100, and then times this by 4 to get 8. So 8 over 100 is 8%. So that's 8. Okay. Now 11 to 18, I have to go look. I'm going to write them all down and then go back. Okay, 15 to 18, none. So that'll be a 0. 19 to 22 will be a 15 out of 25. 23 out of 26 will be a 6 out of 25. 27 out of 30 will be a 2 out of 25. So whatever the number is on the top, I'm just multiplying it by 4 to get the percent. Okay, so my 15 was 0. My 19 was 15, so 15 times 4, just so I don't make a mistake, 20, 60, 60%. Okay, 26, 6 times 4 is 24%. And 27 by 30, 8%. Okay, so we're not done yet. We have to go do the other ones, the ones with the filters. So non-filtered, that was it. Hoping I didn't get backed up. That's non-filtered. Here's filtered. Seems like it'd be backwards. 3 to 6 is 2. 7 to 10 is 2. And if I haven't told you about my handwriting, I'm writing at an angle. That's why it's horrible. Okay, so that's all there was. 1, 7 to 10. Okay, good. Okay, were there any 3 to 6s? Yep. And let's see if there's 25 here. 14, 16, 18, there's 25. So any of these numbers are going to be divided by 25 to get to put them in percents. Okay, 3 to 6 is going to be an 8%. Okay, 7 to 10 would be another 8%. Because it's 2 and 2. 2 times 4 is 8. Okay, now this one is going to be 7 times 4, 28%. Okay, next one's going to be pretty big. It's 14 out of 25. 14 times 4, 28. Sorry. 14 times 4. Usually I'll just do it like what's 40 plus 16. That's generally how I do it. So, because 10 times 4 is 40, and then 4 times 4 is 16, so it's 56%. And none of them happen on the other one, so they're all 0. better way. Okay, and close my eyes and nice work, good. Oh, did I miss a question? Okay, does non-filtered be defective? Okay. All you have to do is think about it. The non-filtered should have less tar. Non-filtered, no. Non-filtered, that means there's no filtered, should have more tar. Okay, good. Filtered should have less tar because it's filtered. So this would definitely be a yes, because look at the 19, I'm looking on the filtered side, or non-filtered side. The 9 side, there's like a 60% on a 19 to 22 at 24%. So the non-filtered had a bunch of more tar, but the filtered were more small, lower tars. Okay, because the relative frequency of the higher tar is greater for the non-filtered. That's true. Okay. Okay, so I'm looking at federal patent in 7 years. 675. 675 were due to pilot error. 91 were due to other than human, and 593 weather. 404 something wrong. Okay, so all you have to do, I'm not going to do this one. You guys can do this. Oh, 603 were sabotage. What you need to do is add these up, get a total, and then do 675 over the total and times it by 100. And put that into here. Okay? To get the next one, other than, you would do 991 times whatever the sum is, times it by 100. That's going to go in the other than. Other human error. Weather, 593 over whatever the total is. The total of all of these always goes into the denominator. Whatever you get, it's going to be a decimal, and you're going to times it by 100, put a percent there. Okay? All right. So that's the video. Sorry it drug on so long, and hope it's helping.